Um, Today, we shall look into the software that is Capsmill. In previous class, we have discussed regarding uh, Capsmill. Okay, so today we shall look into the Capsturn, not the mill. Uh, so we have performed an experiment in Capsmill. Uh, so as you know, that caps mill turn is meant for generation of part program by defining the geometry, operation, and finally the simulation. So you need to define the geometry, nothing but the outline. Okay, outline where the cutting action will takes place, followed with operation, as you know. So preferably like it will be plane facing, turning. So following are the operations that will be performed in Capsturn. Milling, you may have facing, side milling, drilling. So these are all the operations that will be performed in milling. So by using all these operations, finally we'll run the simulation and we'll generate the program. So in CNC turn and mill, there we need to manually enter the part program and run the simulation. Okay, that is the difference between these two software. So today we shall do this particular work part. So you will be given a blank of uh, 93 as a diameter, and let the length be 150. Okay, so from that blank you should obtain this particular geometry. You can see the operations like the turning operation has to be carried out, and there will be an grooving has to be done here. So finally we need to get this particular shape. So in Capsturn we always define the outline. Okay, the outline. So we shall start in this. uh, if possible, uh, please uh, take a screenshot of this particular image so that while I'm asking the coordinate, you should be able to reply. So please take down the pic. So I will be defining the coordinates, the outline, what I meant. So I will be starting from here. So this will be my first position, followed with second, third. So below four, fifth, sixth, 7, 8, 9, and finally is the 10th position. So I need to define all this particular coordinate in order to draw this outline. So let us start. So you can right click, open, or you just double click, that is left click. So then your software will open, and this particular software, yeah, you should need a modem, that is the license to run. uh, I will upload this particular video in the YouTube, so for your reference. So here click on create a new part. So click OK. Now it is asking for the job position. So I will define my job position as 130. So I'm using my entire blank as 150, and I am defining it as job position 150, and outer clearance. So depending on the my diagram, so it is 90. So you just give 4 mm extra, so that will be my clearance. So click OK. So this will be the first step. So we are setting up our space. So it's done. Now I need to draw this outline, this complete outline. So for that I have shown you, I need to define this particular points. Remember, in turning you should know that the axis. Okay, so this particular axis we call it as Z, and this particular axis we call it as X. Okay, my cutting, my work part, sorry, my work part will be located in this form, and you know that towards my right side z will be positive, and towards the left it will be negative. Okay. Similarly, the x value towards up it will be positive, and towards down it is negative. So based on this, we need to define. And remember, we are specifying the diameter, the dimension of diameter. Do not consider the half of it. Do not give the x as a 20. Okay, you need to give the complete diameter. Okay, so let us start. Now, here in this, we have three important stage. First one is geometry. You can see here the left bottom corner, and followed with machining, and the last one is tool path. In geometry, so we are drawing the outline. So here to draw that particular outline, I will select draw multi-line and see specify the start point. So that is x comma z. I have shown you the x as well as z axis. So the initial position will be 0 comma 0. Click enter. So the first, this is a multi-line. The next position, so second position, can anyone tell me the second position values? Do not post in the chat box. I am unable to see. You need to enable your audio and let me know the second position. So the coordinate is x comma z. What is x value and what is z value? No answer. So it will be 40 comma 0. So that is done. Followed with third position, this particular point. Okay. So the third position, it will be x will be 40 and z will be, remember, as I said, you should give the negative value. So z will be minus 45. Okay. So I have defined these two particular points. From here, I need to define the third point, that is 40 comma minus 45. Click on enter. So that is done. Followed with fourth position. So fourth position, I know x distance from here, that is 35, and what will be the z? Z will remain same. So that is 35 comma minus 45. So in the similar way, we need to define. Let me zoom and check. Okay, there is some mistake. So let me control Z. So here, so x will be 35. X will be 35, comma Z will be minus 45. Minus 45. Click enter. So let me check my sketch. 35, 45. Okay. I may have given the wrong dimension for the second point. So let me come back. Control Z. Yeah. My second point is, so x has 40, comma minus 45. Okay, done. Second point is done. And the third point is 35, comma minus 45. So now it is perfect. So, and followed with, let me type the coordinates. So that is, fourth point is done. Fifth point. So fifth point will be, so let us check the fifth point. X will be same 35, Z will be minus 50. So 35, comma minus 50. That is done. And sixth point. So if you check the sixth point, so sixth point will be x as 40, z as minus 50. 40 comma minus 50. Okay, next point. So 7th point, x as 60, you can check here, x as 60 and z as 50, 20, that is minus 70. So 60 comma minus 70. This is done and followed with 8th position. So 8th position, x will remain same 60 and z will be 90, minus 90. So 60 comma minus 90. Okay, that is done and followed with 90 comma minus 90 and 90 comma minus 120. So this is my complete outline. So for zooming, so let me click done here, and for in order to fit this particular diagram or sketch to the complete screen, you need to use this particular icon, that is zoom all. Now, so it is nothing but it's a fit. Okay. So the outline is done. So after this, you need to convert this as a part, that is the defined part. So you can click anywhere on the sketch. So we click here. So create part shape. So click S. So this is done. After creating part, you need to define the blank. Okay. So what I will do, I will define blank 150. So the job position will be 130 till, and diameter, let me, so it was around 90. So let me give 94, and I will give 1 mm extra. Okay. So click OK. Now if you see, this is the blue color line. So this is the blank, and from that I need to remove material till here. Okay, particular. And if you see here, and this particular portion has to be removed with the help of facing. Okay, so 2 operation I have to perform, sorry, 3 operation. One is facing and turning, and the final one is grooving. Okay, so facing also can be done with same tool, no issues with that. So the geometry part has been done. We have defined the part and as well as the blank. So later, let me move on to the second stage, that is machining. So as you see, we defined diameter scale. Okay, now if you see, so it has considered the complete sketch. So from here, let us start with operation. Let me go with turning, and here plane facing. So click on new tool. So select the existing tool, click OK, and it is asking for select start X on blank. Okay, or part, anywhere if you want, you can select that. So let me select that particular start, and next select end X. So I need till here. Okay, so this is done. Click OK. So if you want to vary this particular value, you are free to do that. So I am using the existing value. So click OK. So that particular operation has been done. So plane facing has done, and later we shall follow with operation turning, contour turn. So click on the tool. So select the existing tool, and the start point will be this particular point, and the end point will be here. So this will be my end point, and the same the existing data I am considering. Click OK. So now you can see one more line has been formed exactly on the pink color line. So that is the material removal till to that. Okay, by considering the tolerance. Okay. Next, we shall move on to the operation turning. So here I will use finish turn, new tool. So click OK. So start point and the final point. So click OK. So the concept is simple. So turning will be done with less speed and speed. Okay. Now the final operation is the grooving. Okay. So you can see if I zoom here, so this particular material will not be removed in plane facing. So this particular material has to be removed with grooving. So for that, go with operation, turning, groove, select radial groove. Okay, new tool. So select the existing tool and select the groove. So please concentrate here. So you need to select the point this as a first one, okay, and the end point as this one, okay. So the above point you need to select. So I will go with the existing data, click OK. Now you can see that the complete material has been removed. So once this is done, so final step is to check our tool path, like the simulation. So go with simulation and run the simulation. This is the first facing, followed with contour turning. So as you know, in CNC turn, we used to type the program and we need to feed the same program to the software. And based on that, the simulation was performing. Here, what we did, we draw the outline and specified the operation. Now we are checking the toolpath simulation. So this is the final finishing process. Okay. And this is grooving. So now our material, the final finished work part is ready. And here in examination, in case examiner, if he asks for an NC program, so kindly select this NC program, click OK. So click S, so edit. So here you will get this complete part program. This is generated by the software itself based on our operation. That is the how we have defined based on that. So a particular program has been generated. Okay. So let me close this. So this is a program where we can give the data to the software and we can define the outline and we can define the operations, and finally the simulation as well as part program will be downloaded. And is there any doubt in this? Okay, I feel there is no doubt. And next, what I will do, I will consider one more problem. Okay, so that particular problem, yeah. So let me consider this. So I will take new. Okay, so here I have to define in order to obtain this particular shape with a given blank. Okay, the blank, let it be like 110 and diameter as 85. So with this blank, we need to obtain this particular shape. So for this, again, the same process we will carry out. So let me start with the first point, okay, and the second point. See, third point. See, in order to get the curvature, okay, if I flow in this direction, okay, this particular is an counterclockwise. So what I will do, see, for such, I will specify this particular point. Okay, so this will be my fourth point, and here for this particular radius of curvature, what I will do, so let me specify this particular point for fifth one. This is fifth point, sixth and seventh point. Total 7 coordinates are required to obtain this particular outline. So let us start. So file, so I will move on file, new. I don't want to save this. Now based on our sketch, so that is 80 and 100. So I will give the same job position 130 and 84 here, click OK. Okay, again our area is ready. So let us start with draw multi-line. Okay, so starting position is 0, 0, click enter. Okay, Now the second position x will be 40, z will be 0. So 40 comma 0. Okay, second point is done. Followed with third point. So 40 minus 40. 40 comma minus 40. And fourth point will be 40 and sorry, x will be 60 and z will be 40. So 60 comma minus 40. That is done. And fifth point will be x will remain 60 and z will be 80. 60 comma minus 80. Okay. And the sixth point, x will be 80, z will be minus 80. 80 comma minus 80. Okay. And the last seventh point, 80 will be x comma minus 100. So this is done. The outline part is done. So let me fit this. Now, in order to perform the radius, so here we have an option draw radius. So the radius, if you check, it is 10. Okay. So 10. So let me give that specified value 10. And so if I click near, oh, sorry, it has considered Control Z. So let me give it as 10. Okay. So if I click near, I will get that particular radius. And here, yeah, this is done. Okay. And here, once this is done, for example, in case if you have a chamfer, so same I will show here, but in the given sketch, we don't have the chamfer. In some problem, you may get the chamfer. So this particular area is not required. How to do that? So let me consider the particular distance will be given in terms of dimension and angle. That is, let me show you, that is 3 into 45 degree. So let it be the dimensions given. So for that, so here in draw, go with chamfer. So here you have a distance that is 3 and angle is 45. So click, so let me see, you need to come close to the corner and click that particular area. You will get the chamfer. So done. This is also done. And now what is the next step? So you need to define this particular part. So select yes, that is done. And later let me define the blank. Okay. So blank 150 and so here we had 80. So let me take it as 84. 84. So click OK. Okay, and you may ask, sir, is that mandatory Z1? Not required. If you give Z0, it will locate exactly here. No need of doing any facing operation. Straight away, you can start with turning. Okay, and now let us start the operation. So geometry part is done. So let me go to the machining and here operation, turning. So let me start with facing, new tool. So selecting the existing tool. So start point and this will be my end point. So click OK. So that's done. And again operation, turning, contour turn, new tool. So OK. So start and this final point as the last point. So done. And the final is again operation, turning, finish turn. So select the point and the last. Click OK. It's been done. Okay. The finally you can move on with simulation. Let me before that. So mode, tool path, and if I run the simulation, you can check. So first it is facing operation followed with control turn. So my total entire blank I have given it as 150. So that remaining is the blank portion. So final finishing. Okay. So we have done with the problem. Again, in order to check the program, go with NC program, click OK. So it is asking, should I overwrite the existing file? So if you click S, it will overwrite and it will give you the recent program. Okay. So you can see G02, G03, both in circular interpolation clockwise and anti-clockwise, which you have learned in CNC. Okay, so this is the program which is generated using the commands. Okay, by defining the geometry, machining, final simulation that has been done. Any doubts, students? Okay, so I feel let me check with the chat box. Okay, nothing is here, and I will stop the recording